Hi there, welcome back to Ephemeris, the astronomy podcast. I'm your host, Aphelion, and we are currently in cosmology, or we're currently studying cosmology in season 2. And today's episode, as anticipated, will be about Tycho Brahe, is I believe how you say his last name. I know I had a bit of difficulty figuring that out last time, but basically, what we're going to be talking about in terms of Tycho will be along the same timeline as Giordano Bruno, who we discussed in the last episode. If you haven't seen that episode, go check it out. And Bruno died in 1600 and Tycho in 1601, and they're kind of born like 2 years apart, so hence they are along the same timeline. And so, yeah, great place to just get into the biography, slightly condensed biography of Tycho Brahe. He was born in 1946, and he was one of two twins, but his brother died before his baptism, unfortunately. So, yeah, he didn't end up having a twin. He had a lot of siblings, though. So, I think that was a thing with Copernicus as well. But, anyways, he was born a part of a Danish noble family, but when he was 2 years old, he was taken into custody by his uncle. Some people like to frame it as saying he was kidnapped by his uncle, and there's a lot of reasons for why that happened, but we don't have like a concrete answer as to why, so just a really odd fact to mention. Tycho began attending the University of Copenhagen at the age of 12, which, I mean, surely that has to be a sign of a child prodigy. Like, if anybody goes to college at the age of 12 today, it's like, how, you know? And when he went to college, he originally studied law, but then he gained interest in astronomy, and it's something that builds up over the years. Just like with Copernicus, while he was in college, astronomy was still founded on Aristotelian physics, and events like the solar eclipse of 1560 piqued his interest and inspired him to buy an ephemeris and books on astronomy. And luckily, you don't have to pay for this ephemeris, but you can always subscribe. Sorry, very shameless plug there. So, Tycho bought books written by the likes of Regiomontanus, whom I know we haven't talked about much, but really his importance is around the translation of the Almagest and his interpretations of what parts of it are true and what parts of it needed to be remedied. And I mean, that's really all it was. So, Regiomontanus as an astronomer is probably going to be the most relevant when we talk about Tycho and Copernicus reading their works. And just for the record, Copernicus also read Regiomontanus. And he also read John van Purbach. I hope I'm saying that correctly. And his work was also similar. So, anyways, Tycho was reading a lot of books about astronomy. And the rest of his life, pretty much beyond the solar eclipse of 1560, sums up to kind of Tycho having the dedication to create instruments that will make observations more accurate and advance the field of astronomy. So, after the solar eclipse, that became his life motive, pretty much. In the process, he founded two observatories. He worked with Johannes Kepler, which we will talk about hopefully in the next one or two episodes. I know I gotta fit a couple more astronomers between Tycho and Kepler, but those two worked together for a certain amount of time. I don't know how short or long it was. I believe it was a little bit short because Tycho ended up dying and Johannes Kepler got his work. But they worked together, and Tycho observed a supernova which he believed falsified Aristotle's belief that the universe outside the planets is unchanging. And I think that's the theme that's going to stick around for the rest of the episode. So yeah, that's a great place to get into Tycho Brahe's work, so let's do just that. All of the observations he did during his lifetime made him the last major astronomer to work without a telescope. And that means that, not only did we come really far in astronomy without a telescope, it also means that a lot of great things are about to happen once Galileo creates the telescope. But also, that means that Tycho had to do a lot of work to kind of work around or overcome that barrier. And Tycho worked primarily with tools like the sextant and the quadrant, an instrument which he pretty much brought to life through the many ways he used it. And he still held a level of accuracy that was way higher than any of his contemporaries. So yeah, and in case you didn't know, sextants and quadrants are basically navigation instruments with arcs that help you determine the angle above the horizon of an object and the angular distance between two objects in the sky. And your quadrant would be a 90-degree arc, and sextant would be a 60-degree arc. So yeah, just giving that little context. As a perfect show of his accuracy, Tycho created the first corrections to errors in observational data caused by atmospheric refraction, which caused objects to appear higher than they actually were in terms of altitude. So that is some very, very precise work. He did it using what is known as a great equatorial armillary. He also used this calculation technique, which I'm going to get into how it actually works. He used a Greek algorithm that used trigonometric identities to do approximate multiplication and division. And how it worked is essentially astronomers would use identities from spherical trigonometry that earlier astronomers had worked on and had been discovered, and he would use those identities to plug in known values and find the unknowns, sort of like, your pre-calculus homework in high school. Hopefully that doesn't bring up bad memories. And yeah, I mean, when those astronomers do it, they're genius, but when you do it, you get a B+ in the class, which is the unfortunate part. And it's also really weird when you think about it, how trigonometry once upon a time used to make people's lives easier because they didn't have to do long multiplication or division, but in the 21st century it just makes your life harder because it's a class you have to take to get into college. So yeah, anyways, bit of a tangent there. The technique to use these trig identities they found is firstly scaling down the factors of the multiplication so that they can go into the argument of cosine, sine, tangent, etc. Then they would take the inverse sine or cosine of that value depending on the identity. Then you use the sum and difference of the inverse cosine and sine values, which are angles, and you take those sum and difference values and you plug them into a specific identity and you scale the numbers up again. So I'll just give a quick example if that doesn't make too much sense. So for example, if you're trying to multiply 720 and 105, you would scale 720 down to 0.72 and you would scale 105 down to 0.105. And then you take inverse cosine of both numbers. So your angles that you would get would be 84 and 44. You'd take the sum and difference of those numbers. You'd plug them into the identity, which in this example that I found online had to do with the multiplication of cosines equaling something else. And once you plug those numbers into your identity and you get a number, you multiply that number by the amount of zeros you took out in the beginning. So in the beginning we took out about like 6 zeros, so you just multiply the number you get from the identity by 10 to the 6th. So yeah, that is a system that Tycho used heavily. It's not the most important thing you have to understand the level of Tycho's work, but it's definitely a cool technique. Some additional facts about Tycho's work: he apparently studied the accurate positions of 777 stars, possibly more, which I think was kind of the work he did in his later years cataloging stars. And he also measured the position of the Great Comet of 1577 for a span of 2 months, and attempted to measure its distance using Hipparchus's parallax method. So we see Hipparchus's work kind of coming full circle. Unfortunately, he was unsuccessful at it, but he did find out that the comet's path was associated with the sun and not the Earth, which is kind of a demystification of a belief that was held for a long time that comets has to do with the Earth's atmosphere and not the sun. So, with that out the way, we should talk about a model that Tycho created, and it's known as the Tychonic system. And it gets very odd, so you'll want to hang in a little here. Tycho proposed a system in which the planets were orbiting the sun, but the sun orbited the Earth as well as the moon orbiting the Earth. And we talked about this in a bonus episode with Someji figuring it out better and earlier than Tycho. But let's get deeper into Tycho's side of this geoheliocentric model he talks of. The first question to ask when you hear about the word geoheliocentric model is why? Why does there need to be a combination of these two different theories, right? Many gave their reasoning for a geocentric system by misinterpreting the motion of objects on Earth, as we've talked about before, and then Copernicus came along. And while we didn't talk about this specifically, he had reasons to believe in a heliocentric theory because he saw contradictions between Aristotle's and Plato's models, and he learned about the work of Philolaus and Aristarchus, which had some alternative theories. So he went along with the idea of the sun being at the center. But why did Tycho feel it was necessary to modify Copernicus's model into a geoheliocentric theory? Firstly, his opinion of Copernicus's model goes like this, quote, "This innovation expertly and completely circumvents all that is superfluous or discordant in the system of Ptolemy. On no point does it offend the principle of mathematics. Yet it ascribes to the Earth, that hulking, lazy body unfit for motion, a motion as quick as that of the ethereal torches, and a triple motion at that." So basically what he's saying here is Copernicus's work is great. It mathematically is quite flawless, and it mends a lot of the problems that Ptolemy's model creates. But basically, his belief in a modified model is because he simply saw the Earth as too heavy to have any motion itself. He didn't want to agree on that part. So that would be his main motive as to why he would want to create a geoheliocentric model. And he also lent towards believing in the Holy Scripture, mentioning a lot of things that get brought up in the Bible. So yeah, looks like he was on the wrong side of history for this one. Tycho, for this reason, twisted the interpretation of aether by attributing it to the role of causing circular motion. He saw it as being lighter than Earth-like materials, which are heavier and more inert. And it's definitely not something other astronomers have done before. They mainly just use it to create a matter that will hold up the universe however it helps their theory do so. So yeah, another argument he raised against the heliocentric model was the lack of stellar parallax of celestial objects when observing them, which is basically him saying, if we're moving around the sun, surely our change in position would be noticeable by the change of angle of the stars in the horizon. He was right, but the problem is it was too minuscule of a parallax for him to calculate. His observational accuracy typically narrowed down to arc minutes, but the parallax of star narrows down to fractions of an arc second. So, unfortunately, that was out of his grasp. He also claimed that the heliocentric theory infers that distance scales between stars versus other planets would be exponentially different, and it just didn't make sense to him. So, yeah, that ended up making him slightly off the mark for how the solar system would function, not necessarily the universe. But in better news, Tycho's lunar theory was great, as quoted from online. Quote, I don't know why I said 19. In 1595, Tycho discovered the variation of the moon's longitude, and that the moon's oscillations on its orbital plane relative to the ecliptic are not a constant 5 degrees, but vary between 5 and 5 1/4 degrees. From this, he was able to reason correctly that there are oscillations in the longitude of the lunar nodes. So, yeah, that is pretty good. I think he minimized the error of the calculation of the moon's orbit to about 1/5 of what the error was when Ptolemy did it. So that is very, very impressive. And we've talked about the supernova, the comet, kind of some of his instruments that he refined himself and made very accurate. And that is some significant work, I will tell you, especially because, we talked about him not having a telescope. The only thing was, it was a bit off about the model. But yeah, that's really it for this episode on Tycho Brahe. If you guys enjoyed listening to this episode, learning about him and his geoheliocentric model, I would sincerely appreciate a follow on Spotify if you're listening there, or a subscribe on YouTube if you're listening on YouTube. And until the next episode, I will see you all later. Peace.